Assalamu alaikum dear student, I am Mr. Kadeem Khan and I am a lecturer in the Institute of Computing, Kuwait University of Science and Technology. Today we will take lecture number 15 of the subject of object-oriented analysis and design, in which we will discuss the class diagram. The class diagram is basically a structured model of the UML. It means that class diagram represents the coding or implementation of the project. This is the discussion agenda. It contains the topics of UML class diagrams. Then we have two types of UML class diagrams, including the domain model class diagram and the system model class diagram. Then we have the UML class notations, and we have the binary association, unary association, aggregation, composition, and inheritance. Okay, and then we have the UML multiplicities, and at the end we will discuss different examples of the class diagrams. Okay, class diagram. Class diagram is very much important building block of the object-oriented programming methods. So basically, the class diagram is in fact a main code or a piece of code which represents certain sort of the functionality and also it used to process the data. Basically, a class diagram is used to show different sort of the classes in and then the relationships among these classes. Also, we have certain interface classes and the associations, which is a relationship, and also the collaboration among multiple classes. The UML is a standardized in a class diagram. It means that UML shows us the standard format of the class diagram. UML shows, in fact, the visual format of using the class diagram. Since classes are the building blocks of the application that is based on object-oriented programming, so as the class diagrams has a proper structure to represent the classes, inheritance, relationships, and everything that OOPS have in its own context. So that means that basically the class diagram is a building block for all application. Every application has at least one class. So the class diagram are basically a proper structure which represent multiple sort of the classes, their relationship in the classes, the inheritance in the classes, and everything that object-oriented programming languages have its own context. Okay. Again, class diagram is a static structure of the diagram, which in fact describe the structure of the system at the level of the classifiers. And the classifier here means classes and interfaces. So basically, in the class diagram, we have certain sort of the classes, and then we have also interfaces among the classes. So interfaces is the relationship in the classes. We will discuss interfaces later on. It shows some classifier of the system, subsystem, or components, their relationships between the classifiers and the attributes in operation and the constraints in the classes. So basically, the class diagram shows one system, or it may be the part of the system, for example, or it may be the component of the system which has certain relationship with each other. And also a class diagram have the attributes, which is the main sections. Attributes mean the data which is processed by the class. And also we have certain sort of the operations. Operation means the function or methods which processes the data. And also we have certain constraints. Constraints here means that certain logical conditions that we want to apply on the classes, that this class can be called in so many times in the particular manners, or it can have particular relation with other class. For example, one-to-one relation, one-to-many, or many-to-many relationships. Some common types of the class diagram are domain model diagram and system model diagram of the implementation of the classes. So we have two different class diagram: domain model diagram and system model diagram of for implementing the classes. So according to my view, the system model class diagram is much better than the domain model because this completely represents the class diagram, while the domain model only represents the domain of the applications. Okay, this is the domain model diagram. You can see that this is one of the class called the book, and these are abstract classes, the attributes of these classes, for example. So, and this is another class author. These are two different attributes in the author class. For example, name. Name is the variable name or the attribute name, and string is the data type of the name. Similarly, we have the biography, and its data type is also string. So these are called the attributes. Attributes mean the data which can be processed by this class. So here you can see there is no function in this class diagram. Again, we have another class diagram, class here, account. Account class has one attribute number and its ID. ID means it is a unique number, and history, and it is in fact arrays and 0 to multiple instances and can be used here in this class. For example, this is the enumeration account state and active, frozen or closed. These are three different states of the account state class, and this class is accessed here. Then we have another class, library class. It has only two attributes. This is another class, pattern class. Also, it has two attributes. You can see name and address, name and address. Here, the data type is not specified. The reason it is because this is the domain model class diagram. In the domain model, we do not specify the operations. We just specify the data types and the name of the class and the relationship among these classes. So we do not provide any operation because it just represents the domain here. Similarly, it is the librarian class. It has three attributes: name, address, and the position. And this class is in fact is accessed here, the search in the search class, because we can search a librarian here. So by name or by the address or by the position, we can search the librarian. Similarly, we have the catalog class. In the catalog class, there are no attributes specified. This is just a catalog, so it means that this is just a database class. Here you can see this is the relations. This is the one-to-many relations. Later on, we will in fact explain the relation in very much detail. It shows that one catalog can access multiple books. There are multiple books in one catalog, or one catalog have multiple books. So this is the relations here. So this a basic usage. Usage means that this is there is use uh, uh, different sort of the labels on that this relations. So usage means this class diagram is used here. Similarly, this class diagram is also used here. So that means this class is calling here. We are calling this class here in these two different class. Okay. So a basic usage relation between two elements indicates that a class requires the presence of another class. In Java, for example, this client class must have an important statement for the supplier. The stereotype uses indicates a user dependency. So that means this class is very much important here, and this class is also very much important here. If this class is destroyed, so this class can be affected, and mostly functionality of the search cannot be workable. It cannot work without these classes. So that's why it is the uses relation means that this class use this class using this class, right? So this was the domain model class diagram. Again, I want to repeat that in the domain model class diagram, we do not specify any sort of the operation or functions. Another class diagram, it is called system model of the implementation of the class diagram. In system models, we specify the attribute as well as the functions. So we specify everything here. For example, you can see this is the Android dot view, and then this is the scope resolution operators and surface holder. Surface holder is the class, and similarly view is the object of the surface holder, and it is used in the Android class. And these are the functions of the classes. These are multiple sort of function. We have plus symbols here. Also we have some minus symbol and the tilde symbols and hash symbol. So what is the symbols and what is their purpose? For example, plus for the public, minus for the private, and hash for the protected, and similarly slash is for the derived, and this tilde operator is for the package, that it is the package function. So it is more complete and more sort of the comprehensive, and also it is complete class diagram. So here, for example, this is the camera demo class diagram. In the camera demo class diagram, we have the attributes here. These are the attributes, and these are the function associated with this class, camera demo. Camera demo class is accessed here, preview. So basically, the preview uses the camera demo to access to be here. Similarly, this class diagram is also accessed here. Here you can see there are two. So that two relation, that means that this class also accesses this one and this class also accesses this class. This is the complete overview of the complete class diagram. Now, dear students, already we have said that there are multiple notation in the class diagram. Now here we will discuss each and every one in a very much detail. UML class notation contains class. A class is a rectangular divided into three parts. Basically like this is a rectangular shape. The class in the UML is shown like in the rectangular shape. For example, employee is a class name, and name is the attribute name which has string data type. ID is another attribute and it is long data type, and salary is another attribute and its data type is double. Similarly, get names is the operations, and set name is also operation, and internal staff is also in operation or method. So these are the operations. So every class is divided into three portions. First of all, class name, then their class attributes, then the class operations. Also, we have certain symbols here. So the symbols are very much important and they have a specific meaning. So minus is for the private, and plus is for the public, and protected is described by the this symbol, that is hash symbol, and static is an underline. If this is a static, then we underline the particular attribute or the function. Now minus means private. Private means that this class can only be accessed, the function can only be accessed or the data member within the class but cannot be accessed outside of the class. Public means that this can be accessed everywhere. Everywhere in the project you can access this class. And protected means this can only be accessed within in their respective childs, but if there is no relations of the inheritance in the class diagram, then the particular protected members or functions cannot be accessed. And static mean which is underlined, that it shared among all members of the class. So one copy is shared among all members of the class, which can be in fact shown by the static. Abstract class. Abstract class is usually named in the italic. This is not the abstracts, it is concrete class. Abstract class are shown in the italic format. For example, this is the our previous example. Here you can see that all are concrete classes because there are no italics class names, but here you can see this book is italic, so that means this is an abstract. Other is concrete, and similarly pattern, librarian, catalog, every the search library, these are the concrete, while only the book is abstract. Right. Now, UML class notations, there you can see that we have multiple lines in the class diagram. First one is called the association, second one is the aggregation, third one is composition, and last one is the inheritance. Now, association, what the meaning of the association? Association relation is shown with the straight line. Straight line, the association relation is shown here. That is the straight line. For example, it is the, in fact, unary association. So that's why the direction of the arrowhead shows that from there to this sides it can be accessed. So this is the straight lines of the arrowhead. So that is the association. Association, for example, here I can show you association. This one is the association relation. What is the meaning by the association relation? Means that exactly the object of this class can be accessed here, and the object of this class can also be accessed here. If this is the just a straight line, so that means this class can be accessed here through the implementing the objects, and this class can also be accessed here in this class implementing the object of the book class. So this is called the association. Here you can see another example of the association, that catalogs can be accessed in the book item, and multiple books can also be accessed in one catalog. This is also the association. Okay. Another relation is called aggregation. Aggregation is in effect association when one class belongs to the collection, for example, instructor part of the faculty, indicated by empty diamond on the side of the collection. Okay, right. This is the aggregation. Aggregation is the empty diamond and straight line. Empty diamond and straight line means that this aggregate class can be accessed in another side. So aggregation means that collectively full classes can be accessed here. This is the aggregation. So it means that camera is accessed here in camera demo. Camera demo is in fact camera is accessed here in the camera demo. This is the that means that this provides services to the uh, this class. As you see that the direction of this arrowhead is toward this, so that means the communication occurs from here to there, not from there to here. So if this is the binary, so that means two-sided. This symbol is also here. That means a two-sided aggregation can be occur. So basically, this the Android hardware camera. So we have multiple cameras here. So then, for example, the collection of the cameras. So all can be accessed here. Okay. Another one is called composition. Composition is also in aggregation, but it is the strong form of aggregation. But here the lifetime is controlled here. Components cannot exist without the aggregate indicated by solid diamond on the side of the collection. So the composition has the solid diamond. This one is the composition relation with the solid diamond. So composition means the strong aggregation. And the lifetime is here important. That components can exist without the aggregate. If this component is destroyed, then it shows that this cannot be accessed. For example, library and catalogs. So catalogs has a strong relation with the library. So that means that without catalogs, library cannot do anything, and we cannot search the books without the catalogs in the library. So we can only search a book or the address or name of the library if they have certain catalogs. So this is very strong sort of the association. Last one is the inheritance. Inheritance shows the child and parent concepts, which shows that if the superclass is can be accessed in their parent's class, then it is the inheritance. By considering that the child class has certain functions which can are particular sort of the objects which can access the parent class. For example, bird is a part of the mammal. Mammal is the superclass, bird is the child class, indicated by triangle pointing towards the superclass. Okay, so this is the inheritance. Inheritance means this you can see there's a triangle pointing towards the parent class. So the triangle pointing towards the superclass means that, for example, there you can see that this is the uh, generalization. Generalization is also called the inheritance. For example, this is the parent of this class. This is also the parent of this class. For example, activity is the parent of camera demo class. So this is the different. We have discussed different sort of the um, uh, notations in the class diagram, and already we have discussed this. Now we again discuss some sort of the relations in the class diagram. The association, we already said that this is the association, but it is the binary association. Binary means the object of A can be declared in the class B. Similarly, object of B can be declared in the class A. Then we say that they have the binary association. For example, through the object of B, we can access do something function. Similarly, through the object of A, we can access operation and services function. We can access the do something function here. Here are the example my b dot service. That means service function is in the B, but my b is the object of B, and similarly my b dot service it can be called here. Similarly, my a dot do something function. Do something function is in the class A, so that's why through declaring the objects in the class B of class A, we can access the function of class A in class B. This is called the binary association. That means we can call both of the class within each other. Another version of the association it is called the unary association. Unary means one-sided. So that means that A knows B, but B knows nothing about A. So that means A knows B, but B do not know, B doesn't know about A. So you can see A, B. So that means A knows about B, knows about B. That means that the arrowhead is pointing towards the B. So A can access the B, but B cannot access the A. So for example, maybe dot service, my B dot service, my B dot service, my B is the object of the B class and service is the function of the B class, but we cannot access the A class inside the B. That is called the unary association. Another one is called the aggregation. We have discussed, but here we are showing it with some sort of the code. Aggregation is an association with a collection members relation. If there, this is the aggregate symbols, and it has the collection members association. So where do something a module dot service. So that means that a module is the objects of the module class, and service is the function in the module class. We are accessing a module dot service function declaring the objects of the module, but here you can see static, which shows collection members. So one or multiple members of the module class can be accessed here. Okay, last another one is called composition. Composition is also aggregation with the life control. Owner controls construction, destruction is the part of the composition. So part objects may belong to only one whole objects. So for example, you can see here, this is the employee class. Employees class a certain relation. Employees class can access the team class. Team class. So here we will define the member 0 new employee. So it will define one instance of the member of the employee, and delete and member 0. Similarly, delete is the we can delete a particular members, so we can also delete. So that means the lifetime is important here. So if once the member 0 is deleted, that means that we cannot access that employee class here. Okay, inheritance is very much important relation in the class diagram. Inheritance means that the parent class is accessible into the child class. Here you can see A is the parent of B. A is parent of B. So that B is the child of A. So class B extends A. Extends is in the relations which shows the inheritance. So that means A is the parent of the B class. So this is also called the base class, and this B is the derived class of A. Now, students, there are multiple inheritance in programming, multiple types of inheritance in the programming language. First one is called single inheritance. When A is the parent of B, this is called the single inheritance. This is called multi-level inheritance. A is the parent of B, but B is the parent of C. So it means C is the child of both A and B, but C is not the direct child of A. C is the indirect child of A through the parent B. This is called hierarchical inheritance. A is the parent of more than that is three classes. So that is the hierarchical inheritance. This is called multiple inheritance. Multiple inheritance means C has two parents, A and B. This is the multiple inheritance. This is not multiple inheritance. Most of the students confuse and take it in the multiple inheritance. That means that B and C, A has more than one child. So that's why it is multiple inheritance. In fact, if C has more than one parent, then it is called the multiple inheritance. This is called hybrid inheritance. Hybrid means that uh, that B and C are the child of A, but B and C also the parent of D. So that means D has the parent B and D also has parent C, but D also has the parent A. So that means D is the hybrid child of A, B and C all. So this is the hybrid inheritance. Now, UML multiplicities. Multiplicity means that how many instances can be accessed in one to or another classes. So associations links on the association to specify one or more details about the relations. In the class diagram, we have seen these labels 0 to dash dash to 1, 0 to multiples or starix means all, 1 or 1 to all. So that means that are 1 to multiple. 0 to 1 means 0 or 1 instances. The notation nm indicates n to m instances. So here 0 to 1 means 0 or 1 instances. If we have the label 0 to 1, that means 0 or 1 but not more than 1 and cannot be less than 0. And also 0 to star x are just star x, means that no limit on the number of instances, including none. Including none means 0. And star x means multiple instances, no limits on the instances. Just star x means 0 or multiple. 1 means exactly 1 instances, only 1 instance. 1 to star x means at least 1 instance. So 1 or more, so that is the at least 1 instances in the class diagram. So all this multiplication means that how many objects we can declare in one class of the other class. If we have this, so that means one instance can be accessed exactly, and one to multiple means only one or more than one instances or the objects can be accessed. Now, this is another example of the class diagram. It has everything. You can see here that this is the customer class. Customer class has only name and address attributes. Students, you can it is better to specify the data types here. So name, it is obviously can be a strings, and similarly address, obviously it should also be the strings, and there is no function in the customers. This is the order class, which includes data and status, two different attributes, and they have calc test function, calc total function, calc total weight function, and so on. Another we have payment, and there is only amount variable are the attributes. There is no function in the payment. Payment is connected with the order through one directional association. So that means this the payment is accessible in the order class. One to multiples. For example, one order has one or more payments, while one or more payments has only one order. Similarly, this is the generalization, which is the inheritance. That means this is the parent class of the credit, cash, and check. So we can provide the payment to the particular buying organization through the credit cards, or through the cash, or through the bank check. So this is the inheritance here. Also, we have order detail. Order details as role name, item name, etc. So order detail is another class having the quantity, text status, and calculate sub total calculates. And also we have another sort of the class item. Item has a relations of the binary association with the order details class, and this is the class name, these are the attributes, and these are the operations. And this is navigibility. Navigibility means that we can navigate navigate this class into this. That means that the object of this class can be called here. So means that either one or many objects can be called here in the order detail, but only one items. That means that only order one order can be called in the order detail, but many order details or zero to many order details can be called in the items. Okay, dear student, this is the end of the lectures. If you have any question, you can drop an email at my ID. My ID is m.kadim@kust.edu.pk. So I will wait for your questions, and immediately I will respond to you as soon as I get your email. And these are the book references. You can study more books as well, and you can also study from the other materials. So these are the best books of software engineering. Thank you very much.